Good afternoon and welcome to Carlam Cymru for session number 2 for maths. This afternoon's session will be run by Alan Walters from Gowerton School. The session will last 45 minutes where Mr Walters will go through the relevant subject content. If you have any questions, please use the question and answer section and we will endeavour to answer your question during the session. This session will be recorded with the recording and any resources uploaded to the e-sgol website in the Carlam Cymru area. Over to you, Mr Walters.
Thank you very much, Mr. Jones. Today we're going to be looking first of all at trapeziums, area of trapeziums. Now you should know that this formula is given to you, it's provided for you in all of the numeracy and maths exams. They don't indicate that they are parallel lines, top and bottom, but there are one pair of parallel sides for this trapezium. This is the formula that's given to you. If you are using it with a calculator, perhaps you need to make sure that you put a multiplication sign in there and a multiplication sign in there. Today, for the majority of what we're going to do, they're non-calculator questions, and then we'll definitely need a calculator for the circles questions later on. So I'm going to go ahead and use this formula now, which is on the front page of your maths and numeracy exams. Okay, so this is a typical trapezium that may be given to you. If you were asked to work out the area of this trapezium, you would identify that the top and bottom lines are your parallel sides. So the formula then for the area of the trapezium is a half. I would put a multiplication sign in there. It's not given in the formula on the front page, so multiplied by, and it's the sum of the two parallel sides, so 3.5 plus 6.5, or the other way around, and then you multiply it by the perpendicular height, which is the distance in between, which is 4. Okay, they may be tempted to give you a value there, but that would be there to throw you. Okay, so if you remember the word bidmas, what we tend to do is we work out what's inside the bracket first. The total of what's inside the bracket is 10, so I will write it like this. It's a multiplication sum, so it doesn't matter which order you prefer to multiply that out. It looks okay to say a half of 10 is 5, and 5 times 4 is 20. Okay, so the area of that particular one is 20, and the unit is kilometers squared because it's an area. Okay, so that's the formula that's given to you, and I'd like you to try this question, or before you try it, I'm only going to pause for a very short period of time. Remembering it's a webinar, you may pause for longer, and when you're ready to resume, press play, and then you should see what I've provided as a solution. Okay, so I'm going to suggest that you try this question. It's identifying the parallel sides, which on this occasion are the two vertical lines. Over to you. I would pause the screen and then play when you're ready. So once again, the formula is the area equals half times the two parallel sides, and the parallel sides are the 3 and the 9, times the distance, the perpendicular distance in between, which is 4.2. Bidmas, work out the brackets first. Now, a half of 12 is 6, so 6 times 4.2. Now, I would probably go and write this on the side then. 4.2 multiplied by 6. 6 2s are 12, 2 down, carry 1. 4 6 is a 24, and this one is 25. One digit after the point in the answer. So I do believe that the area is 25.2, and the unit is centimeters squared for this particular area. Okay, so those are two questions where you're finding the area. You're using the formula in the way that is presented to you on the front page. Those questions could also be used in volume, but that's something that will be dealt with in the third session. I'm going to move on now, and the question I'm going to look at is like a problem-solving question. Let me just try and move down here. Here we are. So you're going to use the same formula because we have a trapezium, okay? And on this occasion, we are given that the area is 90. So we're given the area. So rather than using the formula by saying area equals, I'm going to write the formula down and substitute in the values. So, and then say it's equal to 90. So I'm putting the area at the end. I just prefer the letters that I'm trying to find on the left-hand side. So a half times the parallel sides are the 12 and the 8, or the other way around. So we add them, the sum of the parallel sides, times the perpendicular height. Now, the perpendicular height is there, and I'm going to put a big X like that. Okay, now I'm going to work with BIDMAS again. The bracket comes to 20, so it's a half times 20 times X equals 90. So a half of 20 is 10. So I'm going to drop the times because we tend not to use that in algebra. 10x equals 90. So you're multiplying by 10 on the left. When you take it over to the right, you divide by 10. So we're able to say that the perpendicular height is 9. Now we are trying to find a height. So we're not giving our answer in centimeters squared. We're giving our answer in centimeters. It is a height or a length. Okay, so that's how that particular question is carried out. We fill in, or we substitute in the parallel sides and the area, and then what is left is the letter X, and then we just multiply everything out, move the, in this case, the 10 over to the left, and we're able to work that out. Now we could check that this works by actually saying a half times, in brackets, 12 plus 8, close the bracket, times 9, and it should amount to a total of 90. Okay, so let me just check something. Yeah, there we are. So the next question, the one I'd like you to try is this one. Okay, so remember now the area is 72. So fill in, and the parallel sides are the 5 and the 7. And this drawing could be turned around the other way if they wished. The perpendicular height is the letter Y on this occasion, not X. So see if you can try that. Pause the screen and give yourself a moment, and when you're ready to resume, press play. So assuming you've had enough time to do that, and if not, pause now and then play when you're ready. This is what you should be saying. A half times the parallel sides are 5 and 7, times the perpendicular height, which on this occasion is the letter Y, and the area is 72. Okay, work out the bracket first. A half times 12 times the letter Y is 72. Half of 12 is 6. We drop the letter X. There's no need for that. If you want to leave it in, please do so. 6Y is 72. So you're basically saying how many 6s into 72? 12 6s is 72, and it's a distance. The perpendicular height is 12 centimeters. Okay. And we're going to look at trapeziums a little further down the page. I've prepared for you, but those are trapeziums on their own. The trapeziums we're going to be looking at shortly are part of the problem solving question. Okay, so the next question we're going to look at, we do not see a trapezium here. Let me just reduce the size of that slightly. Right, we do not see a trapezium here. What we do see is a triangle, a right angle triangle, and a square. Now they've mentioned something here, the word congruent. They have said, if you're uncertain what this word congruent means, it means the same as. So what they're saying is this triangle has the same area as this triangle, right? One has been it's been turned around. Okay, it's been turned around clockwise, or rotated clockwise like that. Okay, or anti-clockwise, it doesn't matter. Right, so what they go on and ask further down is the area of the whole shape, A, E, B, C, D. I'm going to cut that out slightly because I do want this to be as large as possible. They want the area, the combined area of the square and the triangle. Now, as I said, that triangle is congruent to that, so it's quite easy to work out the area of this triangle. You should know the area of the triangle is one of two formulas. It's half the base times the height. The base is 12, and the perpendicular height, I should mention, is 5. So the area of that triangle, which is the same as that, half of 12 is 6, and 6 times 5 is 30. Okay. So the area of that triangle is 30 centimeters squared. Right. Some people, I'll just mention it, they tend to turn this into a rectangle, and then they'll say 5 times or 12 times 5 is 60, and then they share 60 by 2, and that gets you the same answer. So that is preferred by some people, and that's great. So we've got a square here, right? And this square, you would multiply the length by the width, but we haven't been given the length. So this is where you've got to sort of picture how it all sort of fits together. There's a right angle there, and opposite this right angle, the hypotenuse is what we tend to call it, but opposite the right angle is the longest side, 13. This is a right angle, and opposite this right angle is the side here, this 13. Okay, so if you want to, and you've got time, cut out something like that, turn it clockwise, and you'll see that the longest side is opposite the right angle. So if that is 13 across, that is 13 centimeters down. And of course, the area of a square is a very simple formula. It's the base times the height, or the length times the width, whatever you want to call it. 13 times 13, and you might want to do long multiplication. Or you might just say 10 13s are 130, 3 13s are 39, and when you add them together, they give you 169. So we've got the area of A is 30, and the area of B is 169. How do we work out the total area? Which is what the question asks us, and I say I've covered that. The total area is found by adding these two values. Now, just putting one number on top of the other number is not showing the method. So I'm going to put a big plus sign there, or if you wanted to write it across the page, that's up to you. So 199 centimeters squared is our area, the combined area, it's a compound area of A and B. Okay. That's a typical problem solving question I've seen in maths. Right. We'll push on now for another one. If you want to pause and study that in more detail, please do so. Press pause and then play when you're ready. Right. Okay, I'll just mention this question, read it to you first, right? They've said the area of this triangle is 12 meters squared, and they want the area of the trapezium. Okay, now we've done the area of trapeziums in the first few questions, and what we need is the perpendicular height. In other words, the height going from there to there. We haven't been given that. But what we have been told is that this distance of x, the perpendicular height, is the same as the distance of x there. Okay, so what we're going to do is work out x from the first triangle that's given to you. We're going to work backwards because we are given the area of the triangle, not a formula to find the area. So similar to the questions 3 and 4 that we did with trapeziums, we're going to work backwards. We're given the area of the triangle. We'll find the height x, and when I work out the height x for the triangle, I go and write that on the drawing and write it on the drawing here, and then we use our formula for the area of a trapezium. Now, I would pause the screen when you're ready and press play when you think you've got the solution. Okay, so I'll pause myself for a moment. Okay, I'll take you halfway through at the moment. We've got a triangle. Now the formula for a triangle is half the base times the height, or as I said earlier, you could treat it as a rectangle with a total area of 24, which is double the 12, and we've got the base is 6, and then we try and find the height like that. But I'll stick with the same formula. A half times the base of the triangle is 6, times the height, which is x, is 12. Okay, so I'm going to multiply these out and drop this multiplication sign there. 3x is 12. 3 times what gives us 12? The value of x is 4 centimeters. Okay, so the value of x is 4 centimeters. So I'm going to put 4 centimeters there. Now, if you've got that, you then use 4 centimeters in this formula for the area of a trapezium. Okay, so if you want to try that, pause and then play. Otherwise, I'm going to press ahead and tell you how to work out the area of the trapezium. So I'll draw it out there. A half times the parallel sides are the 6 and the 14, times the perpendicular height, which we've just found out to be 4. Remember in Bidmus, that's 20, so it's a half times 20 times 4. And I'm going to multiply it out as I see it. A half of 20 is 10 times 4 is 40. So the answer is 40, and the unit is meters squared because it's an area. Okay, so that is where we found the letter x from the first part of from the triangle, and once we found x, we then used it to work out the area of the trapezium. Okay, so if you want to digest that a little bit more, just pause and carry on when you're ready. I'm going to carry on here. Another problem-solving question that appeared in one of the past papers. I'll just focus for just a moment. They've described the rectangle as A, B, C, D. There's A, there's B, there's C, there's D. Okay. They also mention you're not drawn to scale, and that's been on nearly every question so far. So don't go getting out the ruler and trying to measure anything. These are just sketches, but obviously drawn up with rulers. They've said XB is 2.5 centimeters. There's the letter X. And there's the letter B, so it's 2.5 centimeters. DC, there's D, and there's C is 12 centimeters. And they've mentioned the area of the triangle ADC is 60. Okay, so this is the triangle. There's A, there's D, there's C. So they've said this triangle is 60 centimeters squared. Let me just clear some of this from here. So the triangle ADC, the one I've shaded in, is 60 centimeters squared. So it's important you can read that information and write what you need to write on the drawing. So the area of this is 60 centimeters squared. So like the question we had above, we've got a base and we need this height. I'm going to call it H on this occasion. Okay, because this H, whatever it'll be, will be the same here. Because what we are asked, when you have more time to read the question, we're asked to work out the area of triangle XBC. There's X, there's B, there's C. So we're given information on this triangle. We're going to find the letter H. And once we've got the letter H, it's the same letter H over here. And then we work out the area of this triangle, which is what we're asked down here. Okay, so if you want to pause the screen and try it, and I'll just play, I'll resume in just a moment. Okay, so if we look at the first triangle, and I'll sort of sketch it out here. The area is 60, the base is 12, and we want this height. I called it H. So I will say a half of the base times the height is equal to 60. So like we've done in a few questions above now, 6H is 60. So in other words, 6 times what is 60, 6 times 10. Okay, so the height is 10 centimeters. So I'm going to put 10 centimeters there. From there to there. Okay. So I'm asked to work out the area of this triangle I've just shaded in red, the triangle XBC. So I've now got all the information. So area equals a half times the base. It doesn't matter which way you choose, which one's the base. I'm going to say 2.5 is the base and the height is 10. Now personally, but it doesn't matter, I don't want to work out a half of 2.5. I'm going to say 2.5 times 10 is 25, and then a half of 25 is 12.5 centimeters squared. Okay, but there's a few ways you could do that. Right, pause the screen if you want to digest that a little bit more. I'm going to now go on to circles. So we're now going to look at area of circles. Now there's a couple of key formulas there. I would focus, by the way, these particular formulas. The formula for the trapezium is given to you on the front page of your exam. Triangles are not, squares are not, and so on. Circles are not given to you on the front page of the exam. There's two formulas to remember. One is pi r squared, which is what we're going to use for most of the questions below. So make a note of that now, because we are going to use that in the questions below, pi r squared. People often mix up that with the other formula, and the other formula is circumference is pi times the diameter. We're going to use that possibly in one of the questions later, but this is what we are using for most of what's in front of us. Now, just for me to recap, the diameter is the distance from end to end through the center, and the radius is the distance from the middle to the edge. Okay, so it's about not mixing those up. Sometimes you are given the diameter and you have to halve it to find the radius. Sometimes you are given the radius, which is from there to there, and we just go ahead and use it. Okay, so we'll look at, there's a number of varied questions coming up now. This is the first question. You have to have a strategy with all these questions, a method that sort of works out. We're asked, it's a circular picture frame, and we're asked to work out the area of this sort of like pinky surround. Okay, so what we basically need to do is you work out the outer area. So we have an outer area like this. We've got an inner area like this. And we're cutting out from the, we work out the area of the outer circle, and then we cut out the inner circle. So imagine, work out the area of the outer circle, and then you'll be cutting that out, and you're left with what I would call the pink surround. Okay, so using the formula, the outer circle has a radius of 16 because it's 12 plus 4, because it's 4 there, and the inner circle has a radius of 12. Now, higher tier pupils may do this all in one line, but we are going to split it up. So the outer area is this. Outer circle is, oh, by the way, I'm going to use 3.14. You can use the pi key on the calculator. More often than not, when we round things to one decimal place or whatever the examiner may wish for, the error is taken out. So I'm going to use 3.14 because I'm not sure if you can use the pi key or not, and I don't have time to go through that now. So the formula is pi r squared. I've told you pi is 3.14 just for today, and if you were in a non-calculated exam, you would use 3.14 anyway. So the outer circle is pi r squared, so it's 3.14 times 16 squared. You need a calculator to work that out. You could work out 3.14 times 16 times 16, or you could use the x squared key on your calculator. Okay, so I've actually gone ahead and done that, and I've ended up with 803.84. Now, it's important to say we do not round at this stage. If I want, and we'll say today, I want all my answers to one decimal place, I do not round at that point. I save all my rounding to the end. So that's the outer circle. The inner circle. Same formula, pi r squared, but on this occasion the radius is 12. And I've gone and worked that out, and it's 452.16. So as I've shown in this strategy or this method above, it's the outer circle, take away, so make sure you've got a big take away sign there, otherwise you're not showing the examiner your method. One value, take away the other value. You're allowed a calculator, so just tap it out on a calculator. 351.68, and you may be asked to round it to one decimal place, in which case you would say 351.7, and in this case centimeters squared, depending what the examiner is asking for. Okay, so I'll repeat, don't round these values at this stage. Leave it to the end. Try and decide what's being given to you. So we've got a radius of 16, a radius of 12, and then come up with a strategy, because it's a problem solving question. Okay, now have a look at that in your own time. Pause if you wish. There's another question here. It's a fraction of a big circle. What's happened is, there's your circle, and it's a fraction, and the fraction you should spot is that it's a quarter. So in this particular case, it's the same formula, pi r squared, and the radius is 10. But you can use the fraction key, a quarter times that times that. That's one option. The fraction key normally looks like that on many calculators, and you just put 1/4. Of course, you could use 0.25, or I'll talk about another way in a moment. I've tapped that out on a calculator and I ended up getting 78.5, and it's centimeters squared. Some people will prefer to work out the area of a whole circle and then divide by 4 afterwards, and that's just as good. All right, so that's a quadrant. Right. I'm going to pan down. Yeah, we'll have a look at this question. Now, this is typical of a problem solving question. A circle has a perimeter of 120, so you've got to know what a perimeter is. It fits exactly inside a square, as shown on the diagram. Work out the shaded section. So this is the key to unlocking any distances. Now, perimeter is the distance around, and there's 4 sides to a square, so you should start off by saying 120 shared by 4 is 30 centimeters. So it's 30 centimeters there, end to end, and it's 30 centimeters there. Okay. So once again, we should have a strategy, and the strategy, right, to find the shaded bit, I'm going to suggest you have a square, work out the area of the square, take away the area of a circle, and you're left with the shaded part. So let's see if I can reduce this. Right, so the square is an easy thing to work out. Area of square is 30 times 30. 30 across, 30 down is 900 centimeters squared. Area of the circle, which we are going to cut out, is pi r squared again. So 3.14 times, and this is where we've got to take out time on it. The radius is not given to us. The radius is not 30, the diameter is 30. The radius, diameter goes from there to there. The radius is 15, it's half the diameter. So that's what we need to do. Okay, and I've gone and worked this out. And I've got 706.5. So the shaded area is the square, as I've got here. Take away the circle. So let's show a big takeaway sign there. Write it on a line, separate line below if you wish, but when I take that away, I've ended up with 193.5, and it's centimeters squared. Okay. Right, I'm going to look at one more question. I'm going to skip out a few things here. Something slightly different, problem solving question. and I'm going to look at this one. Okay, now I'll highlight one or two key things. It's a semicircle on top of a square. The square is a width of 10 meters. Okay, so they haven't labeled anything, so we've got to label them. 10 meters across, 10 meters down, because it's a square on the bottom. Now, if this semicircle has a diameter of 10 meters, then the radius is 5 meters, and we've got to make sure that we use the radius there is 5 meters. So it's a problem-solving question about paint. So first of all, we're going to work out the area of the combined shape. So I'll call this A and this B. So A, which is the semicircle, we can either use a half times pi r squared. Now the radius is 5. Right, now I've gone ahead and typed this out, and I ended up with 19.625, and it's the wrong place to round it. I'm going to leave it like that. The area of B, it's a square, so it's an easy one. 10 times 10 is 100. I'll put a few notes there. And so the combined area, the total area, is when we add them. So I'm going to put a big add up sign there, and we add them up to get 119.625, and it's meters squared. Now that's sort of like a question you'd have had higher up the page, but the only difference is now that it goes on, it's more of a numeracy type question. So I'm going to highlight one or two things, and I say pause the screen and look at that in your own time if you wish, but I'm going to just highlight a few things here. A litre of paint will cover 2 meters squared of the wall. So if I'm Peter the painter, 2 meters squared of wall. It's got a 5 litre tin of paint, and it costs £13 for each 5 litre tin of paint. So they're asking how many tins are needed, and then what's the cost. Okay, so pause it and read it again if you wish. I'm going to crack on and just try and finish this question in the allocated time. So we want to work out how many litres or how many tins of paint are needed, and this is what I'm going to suggest. Okay, number of tins needed. Right, so it's this area of 119.625 shared by, now then, if we got a 5 litre tin and each litre covers 2 meters squared, I need to share that by 5 times 2 or 10. And there are other ways of working that out. You can break it down in stages, but each tin of paint covers 10 litres. So if I divide the area of the wall by 10, I've got 19.625. Okay, 0.625. Now there's no such thing as you can't go and buy 19.625. Sorry, what am I saying? 1911. There we are. 11.9625. You cannot buy 11.96 tins. All right, so we need to buy 12 tins. That's what we need to buy. We need to buy more paint than we require. Okay, so that's answering that part of the question. And then the cost of the paint is obviously you're paying for 12 tins of £13 each. Okay, and you might need to do long multiplication there, or you could do 10 13s. If I do this, so like in a separate pen, 10 13s are 130. 2 13s are 26, and if I add those, we've got £156. Okay, so you may break this bit down. You may break this down separately, but that's how you work that out. And I'd suggest you pause the screen there if you need to look at that slower, and I would. Okay, now I've shown you a number of questions. I've just got a few reminders for you. Okay, so I'll switch on to another page. These are the reminders for you. And I should mention as well, all the answers and solutions will be posted to you with the question sheets and the remember sheet that I've got here, right? This is the area of the trapezium, and this is given to you. Remember to put a times, a multiplication in there and there if you are using a calculator or not, right? They're not put in there, and these are your parallel sides, and you could have your trapezium turned the other way. That's using the formula, but sometimes you have to work backwards. If you work backwards, you substitute in, what I did was substitute in the A and the B and the area, and then you work out the missing height. Okay, it could be presented in another way, but those are the two questions I showed you. Then we've got triangles. Now, I've shown you two sort of separate formulas for triangles. This is the one I went with tonight, half the base times the height, but some people prefer to think of the triangle as a rectangle and then share by 2. And just like the question above with trapeziums, sometimes you are given the area of a triangle. I think we did about 3 of these tonight. You substitute first for maybe the base and the area, and then we're able to work out the missing height. So that came up a few times. That's for triangles. And the last one that we managed to get some of these circles questions at, you must not mix up the diameter and the radius. I've said a few things here. The radius is half the diameter, or the diameter is twice the radius. That's what we focused on tonight. This formula, the area is pi r squared. On another day, we'll have a circumference formula, and it's pi times d. They're not given to you, these formulas. You have to learn them and mix them up, and you'll get 0 marks. Okay, and then, as I said, the radius and diameter there. So, yeah, I'm just thinking these solutions will be posted to you. I've done these solutions before, and you can digest those in your own time. Okay. That is exactly what we've gone through. Probably I've written it out a little slower for you to digest. And these are the circles questions. Okay. And that's basically the end of what I've got to say. So circles and all those area questions come up in numeracy and in maths. And yeah, you can't say whether they come up in one or the other. They can come up in both. They can also come up in the non-calculator unit 1 and the calculator unit 2. That's probably all I've got to say on the matter. So good luck, and study the work at your own time.